This video is going to introduce and use the Cartesian coordinate system. Just a little bit of history on the Cartesian coordinate system. In 1637, René Descartes, who was a French mathematician, perhaps one of the famous ones that you all know, invented, well, rather published a paper on his use of this coordinate system. And what he did originally was he used only a single axis, and so he actually used multiple dimensions, but represented the multiple dimensions only on a single axis. He later then changed that into using multiple axes depending on how many dimensions he was working in. And so kind of his methodology, after he kind of refined it a little bit, was to say, okay, if you have two dimensions, take two directed number lines, so number lines as we know, with an origin, and place the number lines such that they intersect at a right angle at the origin of each line. So again, this is talking about two dimensions. There's certainly a one-dimensional case, which is just a single axis. Three dimensions, there would be three cases. But if we were to draw it out, it would look something like you take one axis. Okay, so this is going to be one number line. Here's 0, and then here's +1, +2, +3, and -1, -2, -3. And it would continue on in both directions, and then you would take the other number line, again it's a directed number line, and place it so that it makes a right angle. So it would look something like this, and you would need to make sure that they intersect at the origins. So on this axis, this would, here's 1, here's 2, here's 3, here's 4, and then -1, -2, -3. And you do need the arrows to indicate that the lines are never ending, okay? And so right in here, right at their point of intersection, that would be a right angle, and we haven't defined a right angle yet, but it would be that angle that has a measure of 90 degrees. And so traditionally when we draw this, and I imagine at some point you'd probably run across this, we take the first line, and that would be the horizontal axis. I actually drew them in reverse, it doesn't much matter. And so this horizontal axis would be labeled an x-axis, and we do look for you to label these axes appropriately. Okay, so x, horizontal axis, depending on if you're not working x, sometimes you work in t, so time, for instance, and so it would be the t-axis. And similarly, the vertical axis would be the y-axis. And again, these are just our traditional ones. You might see t and s, for instance, when we get into our physics applications. Okay, and then so this is a two-dimensional case, like I said, and you can certainly add more perpendicular axes as you get into higher dimensions. However, we're only going to work in 2 dimensions. So when we use the Cartesian coordinate system, I want you just to think back, okay, when maybe you've seen this before, how do you use a system? So if I give you a particular point, how do you plot it? And I want you just to pause the video here and answer that question for yourself. All right, and so maybe you've had some time to think that over, and so let's get some practice with it. So P, we're going to graph each of these points, so P of 1, 2, Q, R, S, and T, okay? So remember that the first coordinate, I think it's actually called an ordinate, the first value in a point is telling you the movement in the x direction, and then the second coordinate, or the second ordinate in the coordinate, is the y movement. So this tells me, okay, well, let's see. So the biggest value I have here is 5. So I actually just want to set up my grid here, my system here. So I'm going to number out to 5 in every direction, and typically by default, if you don't label the axes, it is assumed that they are 1. However, maybe a little redundancy is useful. So 1, 2, 3, and then 1, 2, 3, and that would be enough to tell the person that you're communicating this to what the scale is in the x and y direction. And also remember to include the labels of x and y on your axes. Okay, so P is telling me my horizontal movement is 2 units, or sorry, 1 unit to the right. So it would be here, and then I have to move up 2. So 1, 2. And the intersection of those movements would be my coordinate P. Similarly, Q, I would move -3, so that's actually 3 to the left. So 1, 2, 3. Okay, I'm just kind of right there, and then I have to move up 2. And so I would be right about there, would be Q. All right. R is the origin. Origin, in terms of a coordinate, would be represented as 0, 0. And so that would just be smack dab there at the intersection of those number lines. S would be at 3, -4. So move over 3, down 4. And then T says -1 in the x direction, -5 in the y direction. Okay, and so that's, again, just a little brief review of how to use the Cartesian coordinate system. And just one last question for you to all consider is, what are the names of each quadrant? So the number lines divide the whole plane into 4 pieces. So what is a label for this quadrant in the upper right, upper left, and lower right? Pause the video and see if you can answer that for yourself. All right, and so maybe you remember this, maybe you don't. We start labeling the upper right quadrant as quadrant 1. So this is quadrant 1. And then this quadrant would be labeled quadrant 2, so in the left. And then we go in a counterclockwise fashion. So 1 is in the upper right, 2 is in the upper left, 3 is in the lower left, and 4 is in the lower right. All right, and that's a brief introduction to the Cartesian coordinate system.